AviationPros.com is the portal website for AMT, Airport Business, and Ground Support Worldwide magazines. Visit daily for breaking news, industry blogs, and insightful articles from our magazine's editorial team. And don't forget to sign up for our publication's daily e-newsletters. It's all at AviationPros.com.
Hello and welcome to this special edition of the Aviation Pros podcast from the International GSE Expo in Las Vegas. I'm Josh Smith, editor of Ground Support Worldwide, and I'm joined today by Tim Conklin from IFM. We're doing kind of a special live episode here. We got a couple of folks here in the booth, so it's going to make for a pretty, I think, fun atmosphere here, and I appreciate you coming on, Tim, and talking a little bit more with us today.
Yeah, it's great to be here. Thanks for having me. It's nice to sit in the shade, enjoy a little bit of breeze, get out of the sun. It's a hot day here in Las Vegas.
Yeah, I'm right there with you. I don't mind that we're sitting down for a minute here. But hey, so let's let our audience get to know you a little bit better, Tim. Can you share some more about IFM and the message that you and your company are looking to share here while you're exhibiting at the expo?
Absolutely. So IFM, we've been around for 50 years now. We started in Germany. We moved to the U.S. about 30 years ago. And we've always made technology for machines, right? And that might mean a small sensor that goes on a robot in Detroit. It might mean the display that lives inside your de-icer, that hardened HMI, right? Over time, we've sort of adapted and changed what we're doing, and always kind of grown based on what we see the market needs. We're rarely the first people to come out with the technology, but what we'll see is something that can be optimized, and we'll try to release that to make it easy for our customers. So this week, when you walk around, you'll see little pieces of orange all over, right? There's our sensors all over machines, our controllers, our displays. This show is really great for us. We feel like we're coming and hanging out with our friends all week long. These are the people we work with all year long, and then the culmination is getting to see the machines designed at the show. In that vein, this year, we're also launching a radar sensor. So the collision avoidance topic has been a huge topic for the last several years. We saw a hole in that marketplace, and we collaborated with some of the customers here at the show to introduce a sensor that we think addresses that gap. So that's what we're most excited about this week.
Yeah, that's great. Let's talk a little bit more about that collision avoidance technology and how it's being incorporated into ground support equipment. And as you mentioned, it's been around for some time, but I guess, things get more sophisticated when you talk technology. So kind of how did that collision avoidance technology work its way into GSE, and how have we seen it evolve as time's gone on?
The topic's not a new topic, right? We've had ground damage forever. Most of the time, it's estimated at about $1 billion per year or more, right, in cost to the airline. And that includes both damage and then the liability of having to reschedule a flight, book new passengers, all that kind of stuff, right? What we've seen in the last 10 years is this technology has become more democratized. If you look at autonomous cars on the road, think like 15 years ago maybe, Google came out with that autonomous Google Maps car with the spinning chicken bucket on the roof.
Yes.
And that was like $150,000, just that sensor, right? Since then, now we have Teslas that you and I can afford, and that thing drives by itself on the road. So the exact same thing is happening in all industries, where this technology previously was really inaccessible and extremely complex. And what's happened is it's become more simple to integrate, more reliable, and reduce the cost. And that means you can put it on any machine now, pretty much, right? So you might have LiDAR on some machines, radar, some ultrasonic. There's a whole myriad of technologies that customers are now able to actually use themselves. They're no longer waiting for these advanced technology companies to give them something that works out of the box, right? It becomes simple enough that you can take it, plug it in, and make it work on your machine on your own.
Yeah, that's great. As you mentioned, of course, collision avoidance isn't a new topic around the ground support space. The ground damage is not only an issue that's been prevalent in the past, but it's a very costly one too. So I think it garners a little bit more attention from the industry as a whole. And of course, the airport handling manual, or the AHM, has some language about collision avoidance technology. As ground handlers are trying their best to understand what they need from their equipment, what do they need to know? What are the basics for them to essentially comply with AHM 913?
Yeah. So we are only a small piece of what's in that recommendation, right? So there's a set of recommendations, and it even includes how far away the foot pedals need to be from the operator, So it's really about how to make your whole machine sort of safe or safer. The parts that we really help with are the sensing, the aircraft proximity detection part, the control, and then how do you display it to the operator. So sometimes that means lights, sometimes it means an audio alarm, sometimes it means an actual display that gives you a number that says this is how far away you are. So those are really the topics we've worked on to enable that, like the turtle mode, the snail. It all starts with having a reliable way to sense the aircraft. And that has to be something that both can sense it reliably, but also integrates into your machine reliably, right? So like that chicken bucket we talked about on the Google car, that would never work on any of these machines because these machines are moving, right? Mm-hmm. The belt's coming up and down. The de-icer arm is moving around, right? So it's not a fixed position. And that means you need sensing technology that can build into the machine and doesn't kind of stick out and create an opportunity to get damaged or blind spots, that kind of stuff. Once you have a reliable way to measure the distance or where the aircraft is, now you need something to take all those signals and consolidate them. Because it's usually not just one sensor, right? So usually there's a couple ways that you're measuring that. So you need an intelligent controller that consolidates those signals and does some decision making around it, right? And then finally you need a way to show the operator. So really that flow from the time that an airplane is in front of you until the time the operator reacts, that's the piece that we're really helping with. And sometimes you might build that into the machine to slow it down or stop it. That topic gets a little bit harder when you're talking about an ICE machine because ICE internal combustion, because it's it's pretty variable, right? The control itself, when you hit the brake, like in your own car, thinking about you're going uphill, you're going downhill, it's wet, right? You're varying that pressure that you're putting on the brake. The brain inside the machine could do that. The software that goes into that is extremely complicated, right? So right now, that problem is still an unsolved problem. On an electric machine, it's easy. Just tell the motor controller, I want you to go to snail mode, and it's done, right? So there's definitely still some work to be done around that HM913 goal.
When you talk about incorporating that technology into the equipment and building that system and that brain, where is that most frequently done? Is that collision avoidance technology typically an aftermarket solution, or is that technology integrated at the OEM level, or is there a combination of the two depending on a given situation?
Yeah, it's in my opinion, it will always be a combination of the two. Reason being, right? OEMs, when they're designing a new machine, can plan for this, and it's really easy to deploy, relatively easy. With existing machines, you have a varied fleet. It might be, 5 years old, 20 years old, whatever that is, and they're all different brands of machines. It's never going to be the exact same kit for all of them. Mm-hmm. So that's where it depends really on the end users to come up with an approach that they can adapt and then test. That's the hardest part, is you've got 10 different types of machines that you need to do this for. You need to test it on all 10 before you trust it. And an OEM, might be able to deploy a retrofit kit for some of their machines, but they'll never feel comfortable deploying one for an alternate brand that they didn't design themselves. They don't know the works inside and out. So I think it'll continue to be both directions, and that's what we're seeing is both the end users and the OEMs are running full speed at this problem. And I think in that manner, it'll be solved in the near future.
You just touched on the variety of GSE fleets, and I think that's a really important thing to point out. You mentioned just the variety and age of a type of equipment, manufacturers who are making the equipment, but then, of course, ground support equipment isn't one type of vehicle either. We have belt loaders and de-icers that you mentioned, and baggage tractors and things. So it makes sense that the equipment that's going to interface with the aircraft and the fuselage are going to benefit from collision avoidance. But I guess what types of GSE stand to benefit the most from collision avoidance technology? And are there others that aren't top of mind that you wouldn't think of really needing the collision avoidance?
Really interesting question. IATA has a ground damage database, right? So IATA has an idea of what the number 1, number 2, number 3 are and how often it happens, right? When you talk to the end customers, a lot of times the question is, why did it happen? And the easy one to sum it up is to say operator was being negligent or not paying attention. But there are a ton of reasons why it happens, and you'll never be able to control for them all, right? So that's why we're seeing it really on even machines that you wouldn't expect, right? The belt loader, that's obvious. That thing, all it does is drive at the airplane, Same deal with a cargo loader. But other machines, even like lav trucks, right? Or bag tractors. We all saw that video a couple months ago of the bag tractor taking the hard right into the nose of the aircraft, right? Mm-hmm. So safety is more than just approaching an airplane. If an accident happens on the ramp, even if it doesn't hit the airplane, it's still important, right? So that's the thing, is this technology can be deployed on all of these mobile machines around the airplane. And, the first goal might be to avoid aircraft damage, but the secondary goal is you get a safer fleet. And the ROI is amazing. Just on the aircraft damage topic alone, right? We said it's $1 billion or more each year, okay? What we're finding when we're deploying on fleets in the field, the ROI is less than a few months, right? So you pay it back really quickly when you outfit this technology because you're preventing huge cost, and then you get that added benefit of having a safer fleet.
Mm-hmm. Yeah, it makes a lot of sense. Maybe a loaded question here to kind of wrap up the conversation, but when we talk technology, it's never what technologies worked in the past. It's what's technologies coming down the pike next. So that's my question for you. What's next? What can we expect to see in the near and long-term future as it pertains to collision avoidance?
The one I'm most excited about is AI, right? Okay. When ChatGPT
Cool.
came out, how many of us played with ChatGPT for like a month straight and really found out everything it can do? We could take the same idea, right, machine learning models, and deploy them on these machines too. So our eyes, when we look at an airplane, we know what it is, right? Our eyes know, hey, that's a 737. There's certain distinguishing features. Right now, there's not technology in the market that can do that, right? But it could. Mm-hmm. So it's the same story. That's why the Tesla car, it's all cameras. There's no sensors on there. It's all cameras. Our eyes perceive the road, so why can't the car use the same type of sensor? So that'll be the next thing, I think. Within the next year, we'll start seeing AI technologies deployed on the ramp to say, hey, which door am I going to? What kind of aircraft is this? Where's the landing gear? All that kind of stuff, right? And that's going to be a pretty quick deployment, most likely. We already have cameras on these machines. Just put a machine learning model behind it. It should be pretty easy. The other piece is going to be more advanced tracking. So right now, we're starting to see more and more telematics across the industry. That's kind of a buzzword for a few years now. Mm-hmm. We're not really using these tracking for near misses and ground damage, right? So the way you know that a collision avoidance system works is you didn't hit any airplanes. Most of the time, you don't hit the airplanes anyway, right? So how do you know that the system actually worked? You need to have more advanced kind of near miss tracking and operator reporting, so you can go back and train everybody to say, hey, this was close, here's what happened, here's how we need to change. Or maybe you can optimize even the types of machines in your fleet based on how you're tracking these near miss reports too. So I think those two topics will be sort of really easy integrations in the next year or two.
That's great. I think it's going to be pretty exciting to watch it continue to develop. And as I mentioned, with technology, you never really stop talking about it. So I'm sure it's going to be a real interesting topic at the next International GSE Expo and the one after that and the one after that.
For sure.
Yeah, it's really exciting. Tim, I want to thank you for offering your insight into this topic. And if people hear this episode while they're at the show and want to learn a little bit more about collision avoidance technology or IFM specifically, where can they come and find you and your team here at the show?
Yep. So we're outside, down the main lane, I guess, the main thoroughfare when you go outside. Booth number 3433, right between the bathroom and the water cooler. So you can't miss us.
That's perfect. Two important places to know where to go. You're right in the middle of it. That should be easy for people to find. And if people are listening back home or after the expo concludes, they can visit www.ifm.com for more information as well. If you enjoyed this special edition of the Aviation Pros podcast, I'd encourage you to subscribe wherever you download your podcasts, rate and review it, and be sure to share it with your colleagues in the industry. For Tim Conklin, I'm Josh Smith. Thanks for listening to this special edition of the Aviation Pros podcast, coming to you from the International GSE Expo.